Yeah, but I think Optimus 3 is the right version of the robot to, you know, to produce maybe something on the order of like 1 million units a year.
Elon Musk recently had a conversation with John Collison and Dwarkesh, and he revealed a lot of confirmations about the Tesla bot. Elon didn't just say that Optimus 3 is ready for mass production for the first time. He also described very specifically what Optimus will actually do in the real world, where it will work, and what role it will play. The Optimus 3 version will be announced later this month with at least 4 major upgrades, but people won't be able to buy it until next year. According to Elon Musk, the early stage of Optimus won't focus on complex household tasks. Instead, it will handle simple, repetitive jobs that can run 24/7. This is a really important point. Rather than trying to immediately solve the hardest problems like housework or caring for people, Tesla will deploy Optimus in its own factories this year to train it. Factory environments are highly structured, tasks are standardized, and efficiency can be measured directly through output. This is where Optimus can deliver value the fastest and also collect the best data. In another comment, Elon said that in a gigafactory, Optimus Gen 3 could take on about 10 to 20% of the workload currently done by humans. But here's the key part. He was very clear about this. Tesla has no intention of reducing its workforce. This is something many of us worry about, right? That a lot of workers will lose their jobs once Tesla Optimus is deployed in factories. However, Elon Musk said the total number of human workers will actually increase. Why? The difference is that output per person will increase dramatically thanks to robotic support. In the past, an engineer or a worker could only supervise a single production line. But in the future, they'll be able to oversee multiple Optimus robots at the same time. This is how Elon views the relationship between humans and robots, not as total replacement, but as a way to amplify human capabilities.
Over time, as Optimus robots build Optimus robots, the cost will drop very quickly.
Putting Optimus in a global competitive context, Elon Musk also openly compared the Tesla bot to low-cost humanoid robots from China, especially ones like Unitree. Right now, some Chinese robots, for example Unitree, can be sold for as little as around $6,000 to $13,000, which sounds incredibly attractive. However, according to Elon, the real difference isn't the price, it's actual capability. These robots are usually smaller, less intelligent, less dexterous, and not designed to carry heavy loads for long periods of time without overheating.
Our Optimus is designed to have a lot of intelligence and to have the same electromechanical dexterity, if not higher than a human. So Unitree does not have that.
In contrast, Optimus is designed as a true humanoid robot. It stands 5 feet 11 inches tall, can continuously carry heavy loads, operate for long periods without pushing its actuators beyond their limits. And most importantly, it has intelligence and dexterity that match or in some tasks even exceed human levels. Elon Musk admits that Optimus will be more expensive than those low-cost robots, but he stresses that it won't be much more expensive, while its capabilities are on a completely different level. In Elon's view, comparing Optimus to those robots is like comparing a modern smartphone to a cheap landline phone. The price difference isn't huge, but the real-world value is worlds apart. According to the latest information, Tesla has established partnerships with hundreds of Chinese component suppliers, many of which are involved from the early stages of R&D and design. These companies are gradually forming an Optimus supply chain, similar to how Apple built its iPhone supply chain in the past. While final assembly is expected to take place in the US, the core components will still largely come from China. Tesla is reportedly choosing several Chinese companies as partners for the mass production phase of Optimus, including Zhejiang Sanhua for thermal management systems, Ningbo Tuopu for actuators, and Everwin for sensors. Thanks to a fully developed manufacturing ecosystem, China currently accounts for about 63% of the global humanoid robot component supply chain. According to estimates from Morgan Stanley, if Tesla were to completely remove Chinese components from the Optimus 3 supply chain, the production cost per robot would jump dramatically from around $46,000 to as high as $131,000. Meanwhile, Tesla's goal is to drive the price of Optimus down to around $20,000, which makes not relying on China in the short term almost impossible. Another key point Elon clarified for the first time is the role of Grok and XAI within the Optimus ecosystem. According to him, Grok will act as the high-level coordinating brain, while Optimus serves as the hands and feet executing tasks in the physical world. If Optimus robots are the workers, then Grok is the manager, the planner, and the system-wide optimizer. Elon gave a very concrete example if a new factory needs to be built. Grok could analyze the overall goal, break the work down into thousands of different tasks, and assign each task to specific Optimus units. One group of Optimus robots would handle material transport, another would assemble structures, and another would handle inspection and maintenance. Throughout the process, Grok would continuously adjust the plan, reallocate resources, and optimize the timeline. This AI runs the brain, robots do the work model is what Elon believes will form the foundation of future manufacturing. Of course, in that same conversation, Elon once again openly admitted that scaling Optimus production will be extremely difficult. Unlike electric vehicles where Tesla can rely on many off-the-shelf components already available on the market, Optimus basically has no pre-existing supply chain. From actuators, motors, and gearboxes to power electronics, sensors, and control systems, everything is custom designed, built from first principles physics rather than pulled from a catalog. Because of this, Optimus production will follow a stretched-out S-curve, very slow and even painful at the beginning, then accelerating exponentially once the manufacturing bottlenecks are resolved. One of the reasons Elon Musk believes Optimus 3 is ready for this phase comes down to the hands, the part he has repeatedly emphasized as the hardest component of any humanoid robot. According to Elon, from an electromechanical standpoint, the human hand is an almost absurd structure, with dozens of degrees of freedom and incredibly fine force control that humans use effortlessly, without even thinking about it. He said bluntly that he hasn't seen any robot demo with a truly good hand, one that has the full range of degrees of freedom comparable to a human hand, and he claims that Optimus now has that. To reach this level, Tesla had to design everything in-house, from the motors and gearboxes to the sensors and control systems, simply because there is no existing market that offers a real, full-capability robotic hand alongside the hardware. Elon Musk emphasized that Optimus's intelligence isn't being built from scratch. It directly inherits from the AI systems Tesla has already developed for self-driving. As Elon describes it, both Tesla vehicles and Optimus operate on the same simple but profound principle: light goes in, control commands come out. Today's Tesla cars take in about 1.5 gigabytes of video data per second, along with audio, inertial data, and GPS. Yet they ultimately output only about 2 kilobytes of control commands per second. Optimus has to do the exact same thing, except the robot has far more degrees of freedom than a car. If a car only needs to decide whether to steer, accelerate, or brake, a robot has to coordinate dozens, even hundreds of joints at the same time. More and more Tesla robotaxi CyberCabs are being spotted as the April production start date draws closer. Tesla has ramped up CyberCab testing across roads throughout the United States to finalize the last remaining details. Instead of existing only as design sketches or polished promotional videos, real-world prototypes are now revealing clear adjustments to better adapt to today's transportation infrastructure. Recently, Elon Musk appears to have made a major change directly on these test vehicles, sparking two major waves of debate. Some argue that this change undermines the very autonomous nature of the Tesla robotaxi that Musk has long emphasized. Others believe the change could help CyberCab escape production hell. So what exactly is this change? And why did Tesla feel compelled to make it? Yeah, when Elon Musk stepped onto the stage at Warner Bros. Discovery Studios in October 20th, 2024 to unveil the CyberCab, he painted a vision of a future where electric vehicles no longer need charging cables. The sleek robotaxi, with no steering wheel and no pedals, was said to rely entirely on wireless inductive charging technology. Elon Musk confidently stated, "It just needs to back up, park over a pad, and charge." However, by early 2026, as CyberCab prototypes began leaving closed test tracks and moving into public testing areas in Austin and the Bay Area, a different reality started to emerge. A leaked video from a field technician showed the rear of a CyberCab opening up, revealing a standard physical NACS charging port. In a more recent video, a camera captured a CyberCab being plugged directly into a V4 supercharger stall. Notably, the charging port is cleverly concealed beneath an electrically actuated rear panel near the taillight strip. As soon as these images spread across forums like Reddit and X, observers began asking pointed questions. Why isn't it charging the way Tesla previously showed in its videos? Did Elon Musk mislead us once again? To answer the question of whether this is a tech scam or not, we need to look deeper into the nature of Tesla's product development process and the physical limitations that even a visionary like Elon Musk cannot simply paper over with marketing. At the We Robot launch event, The image of a CyberCab autonomously backing into a wireless charging spot created a powerful visual impact, reinforcing belief in a fully automated ecosystem. However, electrical engineers understand that high-power wireless charging is an extremely difficult thermal management problem. When current is transferred via a magnetic field between two coils, a significant amount of energy is lost and converted into heat. The leaked images of a V4 charging port suggest Tesla is facing a tough dilemma. Relying solely on wireless charging would either require the CyberCab to spend far too long recharging its large battery pack, or force the cooling system to operate under excessive load to handle the excess heat. With Tesla aiming to bring CyberCab into commercial production in April 2026, retaining a physical charging port becomes a lifeline, ensuring the vehicle can operate reliably if wireless technology has not yet reached sufficient efficiency. This is not deception, but rather Tesla's way of building a plan B so the project does not collapse if its core technology runs into last-minute issues. One logical point that many observers tend to overlook is the robotaxi business model itself. To achieve fares cheaper than a bus ticket, as Musk has promised, CyberCab needs to stay on the road as much as possible. Wireless charging can serve as a maintenance source at short passenger wait stops, essentially top-up charging. During the 5-10 minutes of downtime between rides, the vehicle can add a few percentage points of charge without any human intervention. However, when the car is depleted after a long shift and needs a fast charge from 10% to 80% to keep operating, today's wireless charging simply cannot match the speed of a V4 supercharger. Hiding the charging port beneath an electrically actuated panel suggests Tesla wants to preserve the wireless aesthetic for customers while still providing ultra-fast charging capability for fleet operations. This is a smart hybrid approach, wireless charging to maintain autonomous convenience, and wired charging to ensure economic efficiency. With plans to begin CyberCab production in April, the biggest challenge for inductive charging is whether Tesla can develop a sufficiently efficient wireless charging system within such a short time frame. The technology has been studied for many years, but fully solving the issues of heat management and energy loss is far from simple. We believe Tesla may use this charging port for conventional supercharger fast charging on the CyberCab. However, in the long term, this wired charging port could gradually be phased out once inductive charging proves its superior efficiency and convenience. Recently, Tesla's Vice President of Vehicle Engineering, Lars Moravi, pointed out that more than 90% of car trips today carry 2 passengers or fewer. He noted that this reality has directly influenced the design of the CyberCab. Tesla has no intention of forcing the CyberCab to handle every possible passenger scenario. Elon Musk has also explained that CyberCab will cover the majority of trips within the robotaxi network, while trips requiring 3 or 4 seats will be handled by the Model Y robotaxi. For higher-end use cases or larger families, the extended wheelbase Model YL can carry 5 or 6 passengers, although it has not yet launched in North America. Finally, for even larger groups or commercial transport, Tesla has introduced the Robovan, which can carry more than 10 people. It's clear that instead of pushing a single vehicle to meet every need, Tesla's approach reflects how transportation already works today. Different vehicles are used for different purposes, all unified under a single self-driving software stack and fleet management platform. Elon Musk stated that for both CyberCab and Optimus, almost everything is new, so initial production will be extremely slow. However, he added that eventually it will be unbelievably fast, with Tesla capable of producing a CyberCab in under 10 seconds at Giga Texas. Of course, CyberCab will be manufactured in a completely different way compared to Tesla's other vehicles. As we've mentioned before, the Tesla CyberCab uses unboxed manufacturing, instead of moving linearly through hundreds of stations like the Model Y. CyberCab is divided into large modules that are assembled in parallel: the front megacasting, rear megacasting, the structural battery pack, a fully assembled interior, and pre-painted exterior plastic panels. These modules are built independently in separate areas and then rapidly joined together in the final assembly zone, using only about 25 stations instead of 150 to 200. Tesla's completion of the dry electrode process for both electrodes, anode and cathode, in its 4680 cells is a very positive sign, showing that the company is not behind schedule and is moving in the right direction with CyberCab's battery technology. This is a major breakthrough, as the dry cathode has always been the most difficult part. Dry anodes were achieved long ago, but cathodes require far more complex techniques to avoid particle cracking, reduced energy density, or higher costs. Elon Musk described this as a major breakthrough and incredibly difficult to scale for mass production. During the Q4 earnings call, Elon Musk stated that fully autonomous vehicles could serve anywhere from 1/4 to 1/2 of the U.S. population by the end of 2026, depending on regulatory approvals. Expansion plans for the first half of 2026 include launches in Dallas, Houston, Phoenix, Miami, Orlando, Tampa, and Las Vegas, with some of these markets still awaiting regulatory clearance. This year is set to be a pivotal one for Tesla's autonomous driving vision, with CyberCab production, its key hardware catalyst, expected to begin in about 2 months. Battery technology for EVs is always evolving and never really stops improving. But when it comes to Tesla's 4680 battery, it looks like it may have already reached its peak. Simply put, it's hit a new high with major breakthroughs delivering maximum energy output while cutting mass production costs by as much as 50%. Thanks to these improvements, Tesla has confirmed that the 4680 battery will be used in the Model Y going forward, and a super long-range version could be launched very soon. This is honestly a huge turning point because, as you probably know, the 4680 battery has only been used in the Cybertruck for the past 2 years, and that truck definitely isn't cheap. Because of that, many people, even industry experts, started to believe that the 4680 battery technology was a complete failure. CATL's CEO Robin Zung even said at one point that the 4680 battery would never work. But honestly, that claim feels pretty ironic because up to now, CATL still hasn't produced a battery that's better than Tesla's 4680. It remains one of the best batteries in the world today. And with the latest upgrades, it's been pushed to an entirely new level, one that could take CATL many more years to catch up to. So let's dive into the latest updates on the 4680 battery and why it might be considered the holy grail of batteries, at least until solid-state batteries truly go mainstream. Tesla first publicly unveiled the 4680 battery at Battery Day in September 2020, when Elon Musk called it the biggest leap forward in lithium-ion battery technology ever. From the very beginning, Tesla wasn't just talking about a new battery cell. It was talking about a complete overhaul of how batteries are designed, manufactured, and integrated into electric vehicles. The name 4680 comes from the physical size of the battery cell, 46 millimeters in diameter and 80 millimeters tall, significantly larger than the 2170 cells that were widely used at the time. But the real breakthrough wasn't the size, it was the completely different design philosophy behind it. So what exactly makes the 4680 battery so special compared to a regular lithium-ion battery? First, we need to clear something up. The 4680 is still very much a lithium battery. Some people think it doesn't use lithium at all, but that's just not true. It still contains lithium, and it even uses nickel and cobalt. What really sets it apart from traditional lithium-ion batteries is its tabless design. You've probably heard about this already, but not everyone fully understands what it means. In a conventional battery cell, there are small metal tabs that connect the electrodes to the terminals. Those tabs become bottlenecks for electrical resistance and heat buildup. Tesla completely eliminated that design, allowing current to flow more evenly across the entire surface of the electrode. The result: less heat, higher power output, faster charging, and improved durability. On top of that, the internal structure is more efficient, which reduces unnecessary materials and leads to higher energy density. The last time we heard official numbers, the 4680 battery had an energy density of around 272 watt-hours per kilogram, and it doesn't seem like that number has changed much since then, at least not publicly. There haven't been any reports of even minor upgrades. But here's the thing. Even at 272 watt-hours per kilogram, the Tesla 4680 cells are still considered among the highest energy density batteries in the world that are mass-produced. Simply increasing the cell size alone allowed Tesla to drastically reduce the number of cells needed in each battery pack. That means fewer wires, fewer welds, and much lower assembly costs. Tesla began producing its first 4680 cells in late 2021 at its pilot facility on Cato Road in California. But this wasn't full-scale commercial production yet. It was a pilot line where Tesla was both manufacturing and learning how to manufacture at the same time. Those early cells were mainly used for internal testing, evaluating durability, energy density, fast charging capability, and especially how stable the cells were when integrated directly into the vehicle's structure. This testing phase lasted nearly 2 years, and it wasn't until 2023 that Tesla finally started deploying the 4680 battery in the Cybertruck. Okay, on the surface, this all sounds like a smooth journey from research to production to real-world use. But in reality, the 4680 battery hasn't been nearly as perfect as many people expected. That's exactly why it spent years being used only in the Cybertruck, why costs stayed relatively high, and why production ramped up so slowly. We mean, if a battery is truly that good, it should be showing up across multiple Tesla models, right? The truth is, from 2020 to 2023, Tesla's 4680 battery only used a dry anode while the cathode was still made using the traditional wet process. This essentially created a hybrid version of the battery far from Elon Musk's original vision. Tesla simply couldn't fully master the dry process cathode, which is the most complex and expensive part of the 4680 battery. Because of that, Tesla was forced to keep massive drying ovens and toxic solvent handling systems in place. In the end, that wiped out many of the promised advantages in terms of factory footprint and cost reduction. This technical bottleneck caused the earliest batches of 4680 cells to have lower energy density than the older 2170 cells, pushing Tesla straight into what many would call a production hell. Reports showed that early on the battery materials were prone to cracking, had poor adhesion, low yields, and high defect rates, driving real-world costs far beyond initial expectations. Elon Musk himself admitted that scaling dry electrode technology was much harder than expected, and that even a tiny deviation could break the entire production line. That's why many experts and even Cattle's CEO publicly claimed that the 4680 battery was an unrecoverable failure. Given all of that, Tesla had little choice but to use the Cybertruck as a real-world testing ground for the 4680 battery. The Cybertruck has a completely new vehicle architecture, a large and heavy body, a high price point, and enough margin to absorb the cost of an unoptimized battery. On top of that, Cybertruck production didn't need to be massive in the early stages, which allowed Tesla to manage risk if the battery ran into problems. By contrast, high-volume models like the Model 3 and Model Y simply couldn't afford to adopt an unstable battery technology. Even a small issue could affect hundreds of thousands of vehicles per year, and that's a risk Tesla wasn't willing to take. Because of all that, for nearly 2 years, the 4680 battery was almost exclusively associated with the Cybertruck. That created the impression that this technology had either failed or hit a dead end. However, the latest updates suggest that Tesla has finally solved its biggest bottleneck, the dry electrode process for both the anode and the cathode. In its Q4 update and fiscal year 2025 report, Tesla stated that it is now producing 4680 battery cells with both electrodes manufactured using the dry electrode process. And Elon Musk has since confirmed on X that making the dry electrode process work at scale, which is a major breakthrough in lithium battery production technology, was incredibly difficult. Congratulations to the Tesla engineering, production, and supply chain teams and our strategic partner suppliers for this excellent achievement. The disclosure was highlighted on X by Bone Eggleston, Tesla's vice president of 4680 batteries, who wrote that both electrodes use our dry process. Previously, Tesla could only apply parts of this process, or it had to fall back on the traditional wet electrode method at certain stages, basically wiping out most of the cost advantages. Now, with toxic solvents completely eliminated, Tesla no longer needs massive energy-hungry drying ovens that take up huge amounts of factory space. According to internal estimates, factory floor space can be reduced by up to 90%, while energy consumption per battery cell drops significantly. This is the key reason why, for the first time, the 4680 battery is actually cheaper than the 2170 on a per kilowatt-hour basis when produced in the US. Beyond cost, these upgrades also have a direct impact on energy density. Thanks to the dry electrode process, Tesla can use an extremely low amount of binder, only about 1 to 1.25% compared to 3 to 5% in conventional lithium-ion batteries. Less binder means more room for active materials that actually store energy. As a result, the energy density of the 4680 cell improves by an additional 5 to 10%, not because of a brand new battery chemistry, but because of better physical structure and material optimization. This type of improvement is far more sustainable, lower risk, and easier to scale than racing toward unproven battery chemistries. Another major upgrade shows up in durability and lifespan. In wet electrode manufacturing, solvents and high-temperature drying can damage the microstructure of material particles, especially on the cathode side. The dry electrode process helps preserve particle shape and bonding, reducing cracking over time. Test data suggests that the new generation 4680 cells can retain around 90% of their capacity after 2,000 charge cycles, which is an extremely impressive figure for long-range EV batteries. This not only extends vehicle lifespan, but also significantly increases the battery's value for second-life applications like grid-scale energy storage. On the cell design side, Tesla continues to refine its tabless structure, which has always been a major advantage of the 4680 battery. With current distributed more evenly, heat generation during charging and discharging is significantly reduced. In the upgraded version, Tesla further improved axial heat dissipation, allowing the cell to handle higher currents without increasing its size or adding more complex cooling systems. This opens the door to more stable fast charging, especially critical for long-range vehicles and heavy-duty electric trucks. Another area that doesn't get much attention but is absolutely crucial is manufacturability at scale. With dry electrodes, Tesla can build microfactories, smaller battery plants with extremely high throughput. Instead of pouring billions of dollars into a single massive gigafactory, Tesla can replicate many smaller production lines, each delivering far higher output than before. According to Elon Musk, at optimal scale, throughput could be as much as 10 times higher, while total battery costs could drop by 20 to 50% depending on the application. This is an advantage that competitors are unlikely to catch up with in the short term, because most of them are still locked into traditional wet electrode manufacturing processes. But that's not all. Another important piece of information is that Tesla has also confirmed it will use this battery for the Model Y. Very few people actually know that the Model Y was already equipped with 4680 batteries 3 years ago, and it failed to create the impact everyone expected. In the end, those versions were discontinued. So why is Tesla returning to the 4680 battery for the Model Y? Tesla's decision to bring the 4680 battery back to the Model Y is not random, nor is it simply a matter of the technology is finally ready. Behind this move lies a long chain of strategic commercial and geopolitical shifts, reflecting how Tesla is adapting to an increasingly unstable global battery supply chain. At Battery Day on September 2020, Elon Musk promised that the 4680 battery would cut battery costs in half, significantly increase energy density, and serve as the foundation for a Tesla priced around $25,000. At the time, the 4680 was not just a new battery cell, it was the centerpiece of a long-term strategy: structural battery packs, dry electrode technology, high-speed manufacturing, and next-generation battery factories. Expectations were so high that Elon himself later admitted Battery Day had set too many goals at once. The first major turning point came in April 20, 2022, when the first Model Y vehicles produced at Gigafactory, Texas using 4680 cells and a structural battery pack began delivery, but only to Tesla employees. This was a real-world testing phase where Tesla accepted risk in exchange for data. By December 20, 2022, Tesla announced that 4680 battery production had reached 868,000 cells per week, enough for roughly 1,000 Model Y vehicles. On paper, this was a major milestone signaling that the technology had moved beyond the lab. However, reality was far more complex. It wasn't until April 20, 2023 that Tesla officially launched the Model Y AWD, priced at $49,990 with 4680 batteries for the general public. Before that, the model existed as an off-menu product sold in limited quantities with little to no promotion. This suggested that Tesla was not yet fully confident in scaling 4680 battery production, especially when compared to the far more mature and stable 2170 and LFP batteries. Then in September 2023, Tesla quietly stopped producing the Model Y AWD, with 4680 batteries, removing it entirely from the online configurator. At the time, the most common theory was that Tesla needed to allocate its limited 4680 battery supply to the Cybertruck, an upcoming model designed around this cell format. That theory was quickly reinforced when Tesla began delivering the Cybertruck in November 2023, and for a period of time the Cybertruck became the only vehicle using the 4680 battery. But things did not turn out the way Tesla had hoped. During 2024-2025, the Cybertruck proved to be a commercial failure. High prices, demand far below expectations, and production that fell short of targets. This meant demand for 4680 batteries dropped sharply, while Tesla's production capability had improved compared to earlier years. Many people believe this is the main reason Tesla returned the 4680 battery to the Model Y, simply because there was an oversupply of 4680 cells. But that explanation is too simplistic and incomplete. In reality, Tesla clearly explained in its financial reports that bringing the 4680 battery back to the Model Y was intended to diversify the supply chain as a precaution against trade barriers and tariff risks. Put bluntly, Tesla is preparing for a scenario in which Chinese batteries, especially those from cattle, are hit with high tariffs or export restrictions to the United States. Against the backdrop of escalating US-China trade tensions, this is no longer a far-fetched hypothesis. You may not realize this, but today, a large portion of Model Y vehicles sold in the US still rely on batteries from external suppliers, including China. These battery cells are very cheap and extremely reliable, but they come with political risk. If new tariffs are imposed or localization requirements become stricter, Tesla's cost advantage could evaporate overnight. In that context, the 4680 battery produced entirely domestically becomes a strategic shield. The key point to emphasize is that Tesla is not bringing the 4680 battery back to the Model Y because it is the cheapest option, but because it is good enough, affordable enough, and most importantly, under Tesla's direct control. With the dry electrode process largely resolved, the cost of the 4680 battery has now approached, and in some cases even fallen below that of US-made 2170 cells. When tariffs and domestic incentives are factored in, the 4680 becomes extremely attractive from a strategic standpoint. This same logic opens the door for future Tesla models to also use the 4680 battery, not because the 4680 is a premium battery, but because it allows Tesla to fully control the entire value chain from battery cells to packs, and even the vehicle structure itself. With microfactories and dry electrode technology, Tesla can place battery plants right next to vehicle factories, cutting logistics costs and responding more quickly to market volatility. The paradox here is that the 4680 battery was once promoted as the pathway to a $25,000 Tesla. Yet Tesla's return to using it in the Model Y is not about immediately lowering vehicle prices, it's about reducing long-term risk. In an ideal world, Tesla would simply choose the cheapest battery available on the global market. But in the real world, where politics, tariffs, and supply chains are increasingly unstable, the battery you produce yourself becomes the cheapest battery in the long run. That's why, in our view, the return of the 4680 battery in the Model Y does not look like a step backward, nor is it a stopgap solution for the Cybertruck. It signals that Tesla has moved the 4680 from an experimental role into a strategic one. And once that happens, not only the Model Y, but future lower-priced Tesla vehicles may also be built around this same battery platform. At this point, Tesla's broader strategy is becoming clearer than ever. The company's plans to scale back or even potentially end production of the Model S and Model X suggest that Tesla no longer wants to spread its resources across low-volume models. In the near future, the Model Y and Model 3 will likely account for nearly all global sales, becoming Tesla's true pillars. Even more notably, Tesla has confirmed that it has no plans to launch a new vehicle, no additional traditional pickup variant beyond the Cybertruck, and no entirely new vehicle lineup coming anytime soon. This may sound surprising, but it aligns perfectly with Tesla's current philosophy of optimization and focus. Okay, in that context, the 4680 battery emerges as a key strategic piece, especially for long-range vehicles in the US market. Tesla is clearly concentrating its efforts on deploying this battery in its best-selling models, not to showcase technology, but to reduce supply chain risk and increase self-reliance. Will this strategy be applied in Europe or China? Most likely not. In those markets, Tesla does not face battery-related tariffs, and locally produced battery cells are simply too cheap. Manufacturing 4680 batteries in the US and then shipping them around the world just doesn't make economic sense. Personally, we're very curious to see whether we're about to witness versions of the Model Y or Model 3 with significantly longer driving range in the near future. What about you? Let us know your thoughts in the comments. We have been hurt far too many times by solid-state battery rumors. For over a decade, we've been promised a miracle cell that charges in seconds and never degrades, only for those promises to vanish like a mirage. For tech enthusiasts, especially those of us who have seen countless revolutions fail to leave the lab, skepticism isn't just natural, it's earned. But today, a pragmatic giant has entered the arena. Geely, the powerhouse behind Volvo and Zeekr, has officially confirmed that its self-developed all-solid-state battery is entering vehicle validation this year, boasting a massive 400 Wh/kg energy density. This isn't a startup dream like Donut Lab and its physics-defying claims. This is an industrial response from a global manufacturing empire. So is Geely finally turning the solid-state battery dream into a reality, or is this just another heartbreak? Let's cut through the hype and look at the cold, hard facts. In the world of batteries, energy density is the single most important factor. Most electric vehicles on the road today, including long-range Tesla models, use NMC batteries, nickel manganese cobalt, with peak energy densities of around 250 to 260 watt-hours per kilogram. If you drive a vehicle that uses an LFP battery, such as the standard range Model 3, the number is even lower, roughly 160 to 190 watt-hours per kilogram. Reaching 400 watt-hours per kilogram is not just a minor upgrade, it represents a performance increase of up to 60%. For drivers, this means a car that currently goes 300 miles on a single charge could suddenly travel 500 or even 700 miles without adding a single extra pound of weight. This is the magic number that allows electric vehicles to decisively outperform diesel or gasoline cars in every aspect. So what makes Geely's solid-state battery so special? Geely is not only China's largest automaker, it also owns Volvo, Lotus, and forward-thinking brands such as Zeekr and Polestar. Its reputation is built on a solid engineering foundation, so when Geely makes a product claim, it is almost certainly true. The company plans to sell 6.5 million vehicles over the next few years and expects to deploy 100,000 autonomous robotaxis. When Geely announced its solid-state battery testing, there was little reason for doubt. The company has a global network of R&D centers and the manufacturing capability to produce millions of vehicles every year. As you know, China has vast material resources, allowing it to achieve major advances in battery technology faster than most other regions. Since the mid-2010s, Geely has been building its own battery ecosystem. A robust LFP design that reaches about 192 watt-hours per kilogram, among the highest in the industry. This battery is nearly indestructible and charges faster than most others in its class. However, Geely also understands the limitations of LFP. It can never be the holy grail, because its energy density is almost impossible to push beyond 200 watt-hours per kilogram. That's why Geely has been researching solid-state batteries for about 10 years, focusing on cell chemistry, solid electrolytes, and integration methods. The company has a dedicated research division and a joint laboratory in China. Recently, Geely confirmed a major development milestone for its in-house solid-state battery. Unlike the rumors or hype surrounding many other solid-state battery claims, Geely's battery is already at the vehicle-level validation stage rather than confined to laboratory research. In other words, its solid-state battery exists in the real world. Geely has confirmed that it will achieve a complete battery pack and begin vehicle installation validation in 2026. The company is pursuing two different approaches: sulfide-based electrolytes, which offer extremely fast ion transport for high performance, and oxide-based electrolytes, which deliver the legendary safety standards expected by Volvo customers. By reaching an energy density of 400 Wh/kg, Geely is positioning itself as the first traditional automaker to move beyond the liquid electrolyte era. When Geely says it is testing these batteries in actual cars, it means the company has solved the solid-solid interface problem, the biggest obstacle in battery science where layers tend to crack under pressure. However, the fact that Geely's solid-state battery exists in the real world does not necessarily mean you'll be able to walk into a showroom and order a solid-state EV this year. That's because the first vehicles equipped with this technology will be test and validation cars, and there's also the reality that Geely does not sell vehicles in the United States, although buyers in Europe and Australia can purchase its cars. But as we mentioned earlier, Geely is a massive company. In addition to Volvo, it owns Lotus Zeekr and Lincoln Company, so it's not far-fetched to imagine that any of these brands could one day offer solid-state batteries in their electric vehicles and that we could actually buy them. However, in contrast to Geely's solid-state battery, another solid-state battery claiming the same 400 Wh/kg energy density has stirred controversy over the past month. Yes, we're talking about none other than the Donut Lab all-solid-state battery. According to Donut Lab, they confidently claim this is the world's first solid-state battery that can be mass-produced and has a lifespan of more than 100 years. While Geely only states that its solid-state battery reaches 400 watt-hours per kilogram, Donut Lab says its battery can fully charge in just 5 minutes. More strikingly, it is claimed to be the first solid-state battery that can charge smoothly from 0 to 100% without slowing down after 80%, while also maintaining 99% performance from 30 degrees Celsius to 100 degrees Celsius. To be honest, 100,000 charge cycles is absolutely insane. A typical EV battery lasts around 1,500 to 3,000 charge/discharge cycles, which is enough for roughly 15 to 20 years of use. In theory, a battery with a 100,000 cycle lifespan could operate for well over a century. Industry experts, including the chairman of China's battery giant Svolt, have openly called these specifications contradictory and have even labeled the claims a scam. How can a battery have the highest energy density in the world, the fastest charging speed ever recorded, and a lifespan longer than human civilization itself, while also being cheaper than standard lithium-ion batteries? Geely's path, by contrast, is very clear. The company has its Ningbo testing facilities, thousands of patented safety systems, and a supply chain that has already produced millions of vehicles. When Geely announces a 400 Wh/kg battery, it is backed by China's national research programs and a decade of continuous refinement built on its short-blade technology. On the other hand, Donut Lab remains something of an enigma. Some investigations suggest that the company's solid-state batteries actually rely on technology from Nordic Nano, a partner company, but Donut Lab has not acknowledged this. At the same time, Donut Lab has yet to provide independent third-party certification for these breakthrough performance figures. Their batteries are reportedly set to be used in Verge motorcycles, but the automotive industry is still waiting to see whether these vehicles can truly achieve an energy density of 400 watt-hours per kilogram under real-world production conditions, or if this is merely a marketing gimmick. Whether it is Geely's meticulous manufacturing engineering or Donut Labs' bold claims, one thing is certain: the solid-state battery boom is underway. In Europe, politicians are debating a ban on gasoline-powered vehicles starting in 2035. But with Geely's 400 watt-hours per kilogram batteries scheduled for on-road testing in 2026, those bans could become irrelevant. Why would anyone buy a vibrating, polluting, fuel-hungry internal combustion vehicle when they could own a solid-state electric vehicle that can travel more than 600 miles on a single charge-recharge as quickly as grabbing a cup of coffee and is nearly fireproof thanks to the absence of flammable liquids? Clearly, solid-state batteries are emerging as the true holy grail that many companies are striving to attain. Geely is far from the only player investing in this technology. Dozens of major names, including Dongfeng SAIC, Chery, Mercedes-Benz, Stellantis, and BMW, are partnering with battery developers to unlock the secret and bring this breakthrough technology to the mass market. The United States is taking a different approach. Rather than having automakers build batteries entirely on their own, specialized American technology companies are partnering with major auto brands to put their technologies on the road by 2026. Factorial Energy, based in Massachusetts, is a notable example. The company is working with Stellantis, the parent company of Jeep and Dodge, as well as Mercedes-Benz, to equip a test fleet with its solid-state batteries later this year. This test fleet represents the final step before these batteries can be sold to the public. Another major U.S. company is QuantumScape. After years of development, it plans to launch its Eagle Line pilot manufacturing facility next February. This production line is designed to manufacture solid-state batteries for the Volkswagen Group. According to the company, full-scale mass production is still 1 to 2 years away. But the start of automated production in 2026 is a strong signal that the technology is nearly ready for real-world deployment. In other news, in the early days of 2026, Tesla CyberCab prototypes were officially transported to the icy terrain of Alaska to undergo some of the most extreme winter testing imaginable. This marks a critical validation phase before the steering wheel-free robotaxi enters mass production in April 2026. In Alaska, Tesla engineers are focusing on pushing the Tesla Vision system to its limits, the heart of the vehicle, which relies entirely on cameras for navigation. In conditions of heavy snowfall, dense fog, and roads covered in black ice that completely obscure lane markings, the CyberCab's artificial intelligence must prove its ability to localize itself and maintain absolute safety without any human intervention. In particular, to address the long-standing weakness of cameras in winter conditions, Tesla has equipped these test vehicles with a dedicated rear camera washer system, ensuring clear visibility despite dirt and road salt buildup. Beyond autonomous driving, Alaska also serves as an ideal laboratory for testing battery performance and wireless charging technology. In sub-zero temperatures, inductive power transfer efficiency can be affected by thick layers of ice accumulating beneath the vehicle, and Tesla must ensure that charging efficiency remains above the promised 90%. These prototypes are also fitted with specialized winter tires to fine-tune traction control algorithms, helping prevent slipping on icy surfaces. Winter testing in Alaska demonstrates that Tesla is preparing to deploy the CyberCab across a wide range of climates in the United States. Low temperatures, snow ice, and reduced traction represent some of the harshest conditions for autonomous driving systems, making Alaska a logical testing ground for a vehicle designed to operate without a driver. In a post on X, Musk reiterated that CyberCab production is expected to begin in April, reaffirming his guidance on the vehicle's production timeline. Elon Musk also warned that CyberCab production will ramp up slowly, reflecting the challenges of launching an entirely new vehicle platform. In a recent comment, Musk noted that early-stage manufacturing typically follows an S-curve, with initial output constrained by the number of new components and processes involved. According to Tesla's CEO, both the CyberCab and Optimus fall into this category because almost everything is new. As a result, the initial production pace is expected to be very cautious before accelerating rapidly once manufacturing processes are fully refined. At the World Economic Forum in Davos this week in January 2026, Elon Musk once again sent shockwaves through the tech world by declaring that the self-driving problem has essentially been solved. Going beyond theoretical claims, the billionaire laid out an ambitious timeline. Tesla expects to receive approval for its full self-driving supervised system in both Europe and China as early as next month. This is widely seen as a historic inflection point, shifting the focus from development to a phase of explosive global commercial deployment, especially as Tesla's fully driverless robotaxi service has just officially launched in Austin. In the European market, Musk's February target is grounded in reality, thanks to a roadmap already agreed upon with the Dutch Vehicle Authority. Tesla is pursuing a smart strategy by seeking a national exemption in the Netherlands rather than waiting for the European Union's notoriously slow legislative process. If approval is granted by the RDW, a potential domino effect could follow, with other EU member states choosing to recognize the exemption on an individual basis. This would allow millions of Tesla owners across Europe to officially experience FSD for the first time. This confidence is further reinforced by Tesla's extensive FSD ride-along program across Germany, France, and Denmark, aimed at convincing regulators of the system's safety. In China, however, the picture is more complex. While Musk has expressed optimism and Tesla has reached key data security agreements with Baidu, Chinese authorities remain cautious. Sources within the Chinese government suggest that the next month timeline is not realistic as safety compliance reviews and mapping evaluations are still ongoing, delaying the rollout of FSD V13 on vehicles equipped with AI-4 hardware. Despite procedural hurdles, Musk's confidence in 2026 carries a very different weight compared to previous years. With the arrival of FSD V14 and the vastly superior processing power of the upcoming AI-5 chip, Tesla is steadily turning long-standing promises into reality. The autonomous fleet already operating in real-world conditions in the United States is the strongest proof yet for international regulators that self-driving technology is ready for large-scale deployment worldwide. 2026 could be a breakout year for Tesla's AI efforts. Elon Musk, together with Tesla's supply chain partners in South Korea, has outlined an ambitious vision for AI-5, the next-generation chip widely regarded as the key to unlocking Tesla's future. Far more than a simple upgrade, AI-5 represents a shift from a conventional automotive processor to a compact supercomputer integrated directly into the vehicle. The biggest breakthrough of AI-5 lies in its staggering compute density. According to Elon Musk, a single AI-5 system-on-chip delivers performance comparable to an NVIDIA H100 GPU, a $30,000 data center monster that consumes up to 700 watts of power. When two AI-5 chips are paired together, their combined performance could even rival NVIDIA's latest Blackwell B100 B200 lineup. Imagine this: Tesla has effectively compressed the power of a massive data center server into a compact device tucked behind the glove box, running off the car's low-voltage battery and at a fraction of the production cost. This means that every future Tesla vehicle could possess artificial intelligence on par with the most powerful supercomputers in the world today. Why does Tesla need such enormous computing power? The answer lies in FSD unsupervised and the humanoid robot Optimus. While the current AI-4 chip is already running FSD V14, impressively Elon Musk has acknowledged that achieving absolute safety and handling complex traffic scenarios in a truly human-like manner without any driver intervention requires an exponential increase in compute. AI-5 is the solution that makes this vision achievable. It provides ample computational headroom to run deeper, faster neural networks, enabling the vehicle to react instantly to its surroundings. On the supply side, Samsung's factory in Taylor, Texas is set to begin equipment testing next March in preparation for mass production of AI-5 in the second half of 2026. Although AI-4 will remain the primary platform for the CyberCab launching this year, AI-5 is expected to gradually take over as the main architecture starting in 2027. Notably, as the design of AI-5 nears completion, Tesla is shifting its focus toward Dojo 3. If AI-5 is the brain that enables vehicles to reason and act on the streets, then Dojo is the massive server system used to train those brains. The combination of AI-5 in the vehicle and Dojo in the data center creates a closed end-to-end ecosystem in which Tesla maintains full control over everything from hardware to software. Tesla is transforming from a pure automaker into a comprehensive AI and autonomous robotics technology empire. This is no longer just a year of plans on paper, it is the moment when Elon Musk's most ambitious projects begin to bear fruit. At the center of attention is the start of mass production of the CyberCab at Giga, Texas, paving the way for a truly driverless robotaxi network. This milestone, combined with the maturation of next-generation full self-driving technology, is expected to trigger a fundamental shift in Tesla's business model from selling hardware to delivering ultra-high-margin software services. At the same time, Tesla plans to fill the mass-market segment with a new generation of affordable electric vehicles, helping realize its mission of making sustainable energy accessible on a global scale. Manufacturing efficiency is also set to reach new heights thanks to the continued refinement of the 4680 battery technology and the Giga casting process, optimizing costs and reinforcing Tesla's competitive edge amid intensifying rivalry. Beyond vehicles, 2026 is also expected to mark tangible progress for the humanoid robot Optimus as it begins to play a deeper role in Tesla's internal production lines, demonstrating the company's long-term vision of a fully automated future. In short, with the convergence of multiple breakthrough initiatives from robotaxis and affordable EVs to industrial AI, 2026 could be the year Tesla reasserts its identity, even after having lost the title of the world's #1 EV manufacturer to BYD. What do you think about solid-state battery technology, the Tesla CyberCab, and the AI-5 chip? Will Elon Musk succeed with these major projects this year? Drop your comment below. Thanks for watching.